So today we can going to discuss chapter 2 Boolean Algebra. In this chapter they are going to ask for 9 months, two more questions, two questions and 5 more questions. One total they will ask for 9 marks. It's very important topics, very important chapter because it's covering 9 marks. Be concentration, be focused. And next we going for its chapter name is Boolean Algebra. Next we going for introduction for what we need to study. See, Boolean algebra is it deals with the binary numbers. It's called a Boolean algebra. Means an algebra that deals with a binary number system is called a Boolean algebra. Means the algebra. I think you have know about algebra. Algebra that deals with a binary number means binary number means 0 and 1. Deals with a binary number system is called Boolean algebra. And this concept why used for computer in computer subject means it's very power designing for logic circuit used by the browser in of computer systems. Means inside the computer there is a logical circuit. For that for the browsing of a computer system we are going to use the Boolean algebra concept to design the logical circuit. We going to design the logical circuit we need Boolean algebra concept. We must know about Boolean algebra concept to design the logic circuit. The logic gates are building block the circuit of the computer, and Boolean algebra is derived from the name of mathematician. This Boolean algebra, the concept came from mathematician. Then scientist name is George Boole. Is in 1815 to 1864. Who is considered the father of symbolical logic. He is the considered of father of symbolical logic. The Boolean algebra deals with the truth table, true and false, and it deals with 1 and 0 also. And we can say true and false. True means 1, false means 0, and it's also called as a switching algebra. We can call that as a switching algebra. Another name of Boolean algebra with switching algebra. Next we can go for binary valued quantities, variable and constant. See, every day we going to use this. Every day we using the logical decision. For example, in college, what lectures will ask you. So I carry books or not. And so I use calculator or not. You going to ask with someone or with lectures like that. And so I miss TV program or not. In this you will give only two options, yes or no. See, each of these questions require to answer yes or no only. Or you will ask with your friend, did you do you bring bike for college? You will ask with your friend. Your friend will say yes or no. Only two possible. Or you will ask with your friend at your lunch, like that you are going to ask. That time you will say yes or no. Only two possible, like that only. In real life also we using this logical decisions. And next, a variable used for Boolean algebra or Boolean equation can have only two variable. It will be only two variable. The two values are false. False means 0. True means 1. It means we using only two variables. Okay. The two values are, one is false, another one is true. False means we can say 0 also. True means we can say 1 also. Next, a sentence which determine true or false called logical statement. Means we used for determining true or false. Means we will say that logical statement or truth functions. Okay, and the result of true or false are also called truth value. Okay, we can say true logical statement or truth function or truth values. The variable which can store the truth value called logical variable or binary variable. They can store one of the two values, 1 or 0. We can store in that in a true we can store 1, in false we can store 0, binary numbers. Next, the decision which result into either or yes, true or 1. We can use these three. Yes, also we can use true, also we can use, or we can use 1 also. And next, no, false or 0. It's called binary decision. For binary decision, we are using this concept. Next, we're coming for truth table. How we going to write the truth table? The truth table is a mathematical table, logical computer functions, value and logical expression. Means with the help of logical expression only we are going to write the truth table by using mathematical table with a mathematical table logics. Okay, the truth table is a table whose columns are a statement and whose rows possibly in a scenario. What we have given the questions related that only we are going to see. See, I will give one example. Consider the logical expression. This is one of the example. The logical statement is meals. Ram prefer the rice and roti for meal. Means for the lunch he prepare rice and roti for meal. For the lunch, means a lunch. See, it's two condition means he prepared rice and roti for the meals. Okay, and for that we are going to write the truth tables. Y is equal to A and B, logical operator. See, Ram prefer rice, Ram prefer roti, and meals. Output is meals. See, Ram prefer rice. He did not prefer the rice. Okay. Next, Ram prefer roti. In that he did not prefer. Okay. For so false for the meals is become false. And operation means two condition also must be true for true output and for upcoming output true. And next, see, Ram prefer rice false and Ram prefer roti true. See, he prepared roti but he did not prepare the rice. In AND operation, two conditions also must be satisfied true. It did not satisfied in a wrong. It did not prepare rice. Okay, only they prepare roti. For so it's become false. Next, see, he prefer the rice, but he did not prefer the roti. For so it's become false. Next, and last, you prefer the rice also, and you prefer the roti also. Two also you prefer for a lunch. Because of that, it's become true. Okay. In AND operation means two operations also must to be one for output one. Else it will be false 0 0 0. Okay. See, this is a truth table. See, A, Ram prefer rice. See, false and output become false and false true. Output false. Next, true false output. Next, true means you prefer rice also, you prefer roti also. For meal, two condition, two also you prefer. I think you understand these topics. Next, we're going for logical operators. There are the three operators: not, or, and operator. This operation are now used for computer construction known as a switching circuit. These are used for the computer construction as a switching circuit. There is a three logical operator: not operation, not operator, and operator. Okay, we can see this one by one. And operator is a unary operators. Okay, it's only unary operator only one operator it will be, and this operator has a single variable. It will be only single variable. The operation performed by a not operator is called as a complementations. Okay, the symbol we use for its bar. X bar means complement of X bar. See, if X is equal to its X is equal to 1 means when we do X bar means it will become 0, means it will be 1. Okay, we do X bar means it will be 0, and in case or X 0 means when we do X bar it will be 1. Okay, it is the truth table of an Venn diagram of the not operation. See, for what means, see here x is given 1. Okay, when we do x bar not operation, it will not not be act like a x, it will act like a reverse of that. See, it in case give one example, x 1 means it will act like a 0 when we do x bar. uh, Next we going for OR operations. OR operator is a binary operator. This operates in a two variable. It is operate in a two variable. The operation performed by OR operator is called, it is a logical additions. And the symbol we use for its plus. For OR operation we using the symbol is plus. Okay, example x plus y can read x or y. And read like this also, x or y. The truth table of a Venn diagram for the non-operators. This is the Venn diagram. How it's this truth table is, we need to write, there is a two possibility. Okay, and here 0 0 0 0 1 1 and 0 1 0 1. See here 0 0. Okay, it becomes 0. See here 0 1 1. Because O means in case one operator have 1 means it will become 1. Any one. Okay, let's see here 1 0 dash 1, and let's see here 2 also 1, so it becomes 1. In case any one operators have 1 means the output will become the 1. It's a OR operators. Next we going for AND operator. AND operator is also binary operator. This operator operates in it. It's also two variable. The operation performed by AND operators is called logical. It's called logical multiplication. AND operator means it will be logical multiplication. The symbol we will use for its dot. Example C, x dot y can read as x and y. The truth table of a Venn diagram not operator, it's how the truth table is working in C. In two operator also must turn should be 1 to become either true, or else it will be all false. See here x also 0 and y also 0. Because of that the output become 0. Here see next, x is 0 and y is 1. Condition is not satisfied, become 0. See here x is 1 and y is 0. The output become 0. Next, in two condition also, in two operator also 1 1. For so output become 1. And to evolutioning the Boolean expression we using for using truth table, we must know about this fourth step when we do the truth tables. To create truth table is the following steps. First, determine the number of variables for n variable. Create the table with n rows. Means how many number of variable we need to see that. Okay, in case there is a three variable means we need to use this formula 2 to the power of n. See, there is a further 2 variable means then truth table we need 2 to the power of 2. You can say it must be 4 rows. In case we have 3 variable means 2 to the power of 3. Here it must be 8 rows. And list the variable every combinations of 1, 2, true and false for a given variable. Create a new columns for each statement or argument, and we need to create the column for each term, statement or argument. If two statements have same truth value, then they are equivalent. In case the statement have the same truth value, then they are equivalent. Example, consider following a Boolean expression. This expression is only 2 variable. It must be a 4 rows. See, so we have to count the 4 rows. 1, 2, 3, 4. Okay. Create a list variable every combination x and y. Create a new columns of an y bar, because we need to create y bar of the statement, and then we fill the truth value y in the columns. The final column contains the value f is equal to x plus y bar, and we are going to write this x and y. X means we are going to write this possibility. This also must be order 2 times 0 0 and 1, and y 0 1 0 1. To remember this like this also you can remember, in case two variable means 00 and 1 and 10 and 11. 00 0 1 10 11, like this also you can remember. And we're going to do y bar. Y bar means y is 0. When we do y bar it become 1. See here y is 1. When we do y bar it becomes 0. Here see y is 0. When we do y bar it becomes 1. Next y is 1. When we do y bar it becomes 0. Next we went for final result x plus y bar. Okay, there is a plus means we need to use odd operations. See, x is 0, y bar is 1. The conditions, the final result will be 1, because any one of the operators have 1 means it will become 1. Next, see, it's also 0x and the y bar also 0, so it becomes 0. Next we coming for third one, x is 1 and y bar also 1, so it becomes 1. In fourth, x also 1 and y bar also 0, so it's become 1. Next we are going to see the Boolean postulates. It's a fundamental law of an Boolean algebra, or called as a postulates of an Boolean algebra. It's one of the fundamental laws of the Boolean algebra. They are called a postulates of algebra. This postulates Boolean algebra oriented in a three logic function. It would be three logic functions. This and operation is operation and not operations. So the properties we can see this for next class. Today what we have learned not operations, or operation and operation. Next we going to for next class. First we need to understand about these three to write the truth tables. Okay, thank you.